In 1951, a mechanic in Daytona Beach discovered a loophole so brilliant that NASCAR had to rewrite their entire rulebook. His name was Smokey Yunick, and he figured out how to add 50 horsepower to Hudson Hornet engines without technically breaking a single rule. While other mechanics spent hours grinding exhaust manifolds with expensive tools, Smokey used nothing more than valve grinding compound, an air compressor, and thinking that made him the most feared man in NASCAR. This wasn't about cheating, it was about reading rules the way lawyers read contracts, looking for what wasn't said rather than what was written. By the end of this story, you'll understand why this one innovation changed racing forever, and why the battle between rule makers and innovators continues today. Stick around because the details of how he pulled this off are absolutely fascinating. Smokey Yunick didn't start out as a racing legend. Born to Ukrainian immigrant farmers in Pennsylvania, he dropped out of school at 16 and built his first vehicle by cobbling together parts from junked cars into a working tractor. When World War II broke out, he joined the Army Air Forces and became a mechanic on B-17 Flying Fortress bombers. These weren't just any planes. They were four-engine behemoths with massive Wright R-1820 radial engines, each producing 1,200 horsepower through turbo superchargers. Keeping them running at 25,000 feet over Germany, often with engines shot out and fighters attacking, taught Smokey things about airflow and performance that no civilian mechanic could learn. The military taught him that smooth airflow was everything at altitude. A rough intake passage could cost 50 horsepower when you desperately needed every bit of power to stay airborne. More importantly, he learned specialized maintenance procedures the Army Air Forces used for cleaning complex aluminum castings without taking them apart. They pumped abrasive compounds through passages under pressure, the same principle as sandblasting, but controlled enough to polish rather than destroy. These lessons would prove invaluable years later. After the war, Smokey flew over Daytona Beach and decided that's where he wanted to settle. He opened a repair shop he boldly named the best damn garage in town, and quickly earned a reputation for solving problems other mechanics couldn't touch. He always wore a white uniform, a battered cowboy hat, and kept a cigar clamped between his teeth. But what really set him apart was his approach to problems. While most mechanics tried to overpower restrictions with brute force, Smokey outsmarted them. He read NASCAR's rulebook like a legal document, studying every word for what it didn't say. If a rule prohibited grinding but said nothing about chemical treatment, that gap was an opportunity. If regulations specified maximum dimensions but not surface finish, he'd exploit that oversight. Other crew chiefs feared him because they never knew what he'd come up with next. NASCAR officials respected him, but also dreaded seeing his name on entry lists because they knew he'd find some new way to interpret their rules that they'd have to address. By 1951, Smokey had established himself as the mechanic everyone wanted, but nobody could quite figure out. He filed 12 patents during his career and influenced the development of the small-block Chevy V8 engine. His reputation for innovation eventually landed him in the International Motorsports Hall of Fame in 1990. And Disney even based the character, Doc Hudson's crew chief, Smokey, on him in the 2017 film Cars 3. But all of that fame started with one brilliant observation about exhaust manifolds and what the rulebook forgot to prohibit. The question wasn't whether Smokey could make cars faster. Everyone knew he could. The question was how he'd do it without getting caught, and whether NASCAR's rule writers could keep up with his mind. The Hudson Hornet dominated NASCAR from 1951 to 1954. Winning an astonishing 79 races in just 4 years. This remains one of the most dominant stretches in racing history, and it happened with a car most people thought had no business winning. Under the hood sat a 308 cubic inch inline six-cylinder engine, not the V8s everyone expected to rule the sport. The engine used an unusual L-head design, where valves sat beside the pistons instead of above them. Fresh from the factory, these engines produced 145 horsepower, respectable for 1951, but nothing special. The real problem was what Hudson did to those engines during manufacturing. The exhaust manifolds came out of the casting process looking absolutely terrible. Early 1950s quality control was more suggestion than standard, and Hudson's foundries produced manifolds with internal passages that mechanics described as looking like the moon's surface. The casting process left them pitted, uneven, covered in casting flash, and full of restrictions that strangled exhaust flow. Every mechanic in NASCAR knew these manifolds were killing performance, probably costing 20 horsepower just from the turbulence. When exhaust gases try to escape through rough passages, they can't flow smoothly. Engineers call smooth flow laminar flow, where gases move in organized, efficient streams. Hudson's stock manifolds created turbulent flow instead, chaotic and slow, with the exhaust literally fighting itself to get out. Every peak and valley in those rough surfaces created back pressure, and back pressure kills power. The exhaust valve would open and a pulse of 1,500-degree gas would try to escape, only to hit those rough surfaces and lose all momentum. Every competent mechanic knew the fix. You'd take a die grinder with carbide bits and spend 12 to 15 hours per manifold smoothing out the passages. This process, called port and polish, meant opening up restrictive areas, smoothing transitions, and polishing surfaces until exhaust could flow freely. On a good day, proper porting could free up 30 to 50 horsepower on these Hudson engines. Teams with money and time could transform these terrible manifolds into decent ones. Then NASCAR dropped the hammer. Rule 12, Section 4, Paragraph B stated clearly that exhaust manifolds must remain stock as delivered from the manufacturer. No grinding, cutting, welding, or mechanical modification of exhaust passages was permitted. Bill France, who ran NASCAR, wanted stock car racing to actually use stock parts. The cars fans watched on Sunday should be the same ones they could buy on Monday, at least in theory. The rules seemed airtight. No grinding meant no die grinders. No cutting meant no enlarging ports. No mechanical modification meant you couldn't touch those passages with any tool. Every crew chief read that rule and accepted defeat. The manifolds would stay rough, cars would stay slower, and that was that. Except Smokey Yunick read that rule 20 times, then read it again, and then he smiled. The rule said no mechanical modification. It said absolutely nothing about chemical modification. That gap between what the rule prohibited and what it didn't mention would change everything. But first, Smokey had to figure out exactly how to exploit it. Smokey's solution came from combining two things he learned in the military. First, the Army Air Forces had taught him about using abrasive compounds pumped through passages to clean and polish without disassembly. Second, his experience with bomber engines at high altitude had taught him that surface finish mattered more than most people realized. He started with valve grinding compound, a product that had been around since the 1920s. The compound contains silicon carbide particles suspended in oil, essentially liquid sandpaper designed specifically for polishing metal surfaces. The innovation wasn't the compound itself, but how Smokey applied it. He sealed one end of the manifold and connected an air compressor to the other end, but not directly. Using parts scavenged from an old refrigerator compressor, he rigged up a reciprocating valve system that reversed airflow 20 times per second. The compound would rush through the passages in one direction, then immediately reverse, back and forth, with abrasive particles scrubbing every surface they touched. The high points in the rough casting got worn down first because they took the most contact. The valleys gradually filled with worn material that got flushed clean with each reversal. The physics behind this were elegant. Silicon carbide rates 9.5 on the Mohs scale of mineral hardness, just below diamond at 10. When suspended in oil and pumped under pressure, each particle became a microscopic cutting tool, removing perhaps 1/10 of a thousandth of an inch with every pass. Multiply millions of particles, making thousands of passes per minute for 8 hours straight, and the cumulative effect was better than what professional porting shops could achieve with hand grinders. The reciprocating flow meant the compound worked every surface equally, something human hands could never match. The process required precise control. The oil viscosity had to be perfect. Too thin, and the compound wouldn't carry enough abrasive particles. Too thick, and it wouldn't flow properly through the passages. The pressure had to cycle between 20 and 60 psi at exactly the right frequency to create optimal scouring without causing erosion. The manifold had to be positioned so compound could drain and refresh, preventing particle buildup that would cause uneven wear. Get any of these variables wrong and you'd end up with passages that were unevenly worn or barely changed at all. Smokey refined the process even further as he learned. He started heating manifolds to 200 degrees Fahrenheit during treatment. The thermal expansion opened up the grain structure of the cast iron slightly, letting the compound work more effectively. He added detergents that helped carry away removed material. He experimented with different abrasive grades, starting coarse for initial passes and finishing with progressively finer grades until passages were polished to an almost chrome-like finish. Stock manifolds had surface roughness of 250 to 300 microinches. Smokey's chemical porting brought that down to maybe 50 microinches, almost as smooth as a mirror. The results on the dynamometer were staggering. Where stock Hudson 308 engines made 145 horsepower, Smokey's chemically ported versions were putting out 195 to 200 horsepower. That's 50 horsepower from what amounted to industrial-grade toothpaste in compressed air. A 35% power increase without changing a single part. In 1951, the difference between winning and finishing 10th was often less than 10 horsepower. Smokey had just found 50. The beauty of this trick was that it remained technically legal. No tools ever touched the inside of the manifold. No grinding wheels, no carbide bits, no files. Just fluid dynamics doing the work. If you measured the manifold with calipers, every dimension matched the factory blueprint perfectly. The ports were the same size. The mounting surfaces were untouched. NASCAR inspector Norris Friel could spend 3 hours examining every component and find nothing wrong. He could see his own reflection in those polished passages, but he couldn't prove they violated any written rule. Other mechanics tried to copy the technique once a word got out, but they failed because Smokey hadn't shared the critical details. They'd pump regular grinding compound through at steady pressure and wonder why their manifolds came out wrong. The secret was in those details: the reciprocating flow pattern, the precise pressure cycling, the oil viscosity, the positioning, the heating. Without knowing these specifics, copying was impossible. For about $100 in materials and a weekend of time, Smokey had created a 35% power increase. In other terms, that was like showing up to a knife fight with a machine gun. On Daytona Beach's long straightaways, where races still ran on the sand and road course, Smokey's Hudsons pulled away from identical cars like they had rockets attached. And NASCAR officials could do absolutely nothing about it because technically, legally, nothing was wrong. The first time NASCAR officials got truly suspicious was after a race where Smokey's Hudson pulled away from the field on straightaways where it shouldn't have been possible. Technical inspector Norris Friel demanded a teardown. He spent 3 hours going over every component with measurement tools. The displacement checked out at exactly 308 cubic inches. The compression ratio measured stock at 7.2 to 1. The camshaft matched factory specifications. Carburetor jets were standard. Every dimension on the exhaust manifold was perfect. But Norris wasn't stupid. He could literally see his reflection in those exhaust passages when he shined a light through them. He knew something had been done. He just couldn't prove it violated any written rule. In 1951, NASCAR operated on a simple principle. If something wasn't explicitly illegal, it was legal. Smokey stood there with his arms crossed, that cigar clamped in his teeth, daring anyone to show him where the rulebook said he couldn't chemically treat cast iron. Nobody could. The impact was immediate and dramatic. Smokey won 9 races with his Hudson Hornets using this technique. Each win paid about $1,000 in 1951, roughly $11,000 in today's money. But the real money came from Hudson Motor Company. They allegedly paid Smokey $25,000 under the table for his championship support in 1951. That's equivalent to $275,000 today. Not bad for a guy with grinding compound and an air compressor. Other mechanics tried desperately to copy what Smokey had done. Some Hudson teams actually hired chemists to analyze his exhaust manifolds. They found traces of silicon carbide embedded in the cast iron, but by then it was too late. Smokey had already won his races, made his point, and proven his concept. The damage was done. By the 1952 season, NASCAR had caught on. The new rulebook specifically banned chemical treatment, acid etching, or any form of internal surface modification, whether by mechanical, chemical, or other means. They'd closed the loophole, but Smokey had already moved on to his next innovation. He allegedly started soaking cloth air filters in nitromethane and letting them dry, creating a hidden power boost that lasted just long enough to win a race before the evidence evaporated. Smokey became famous for finding loopholes NASCAR hadn't considered. He once built an 11-foot fuel line that held an extra 5 gallons of fuel beyond the legal tank size. When officials measured his fuel tank, it was legal. They didn't think to measure the fuel line. Another time he froze fuel before a race because cold fuel is denser, meaning he could fit more in a legal-sized tank. He put a basketball in the fuel tank during inspection, then removed it before the race to gain extra capacity. The stories became legendary. The most famous incident happened when NASCAR officials confiscated his fuel tank for being too large. Smokey started the car with no tank installed and drove it out of the inspection area. He'd made that 11-foot fuel line hold enough gas to run the engine just to prove his point. Officials were furious, but they couldn't help being impressed. Each trick Smokey pulled forced NASCAR to make their rulebook more specific, but not before other manufacturers also started taking advantage. The impact of Smokey's chemical porting hack didn't die when NASCAR banned it. It evolved and spread to other applications. Racers started using the same principle on intake manifolds, where rules were less specific. They used it on cylinder heads before installation. They found ways to chemically treat parts that weren't specifically mentioned in the rulebook. The innovation Smokey pioneered became standard practice, just applied to different components. Today, professional engine builders still use variations of Smokey's technique. Modern compounds are far more sophisticated, with diamond paste, ceramic media, and engineered abrasives replacing the simple valve-grinding compounds Smokey used. For certain applications, especially in vintage racing, where original parts must be maintained, chemical porting remains the method of choice. The principle Smokey pioneered in 1951 remains fundamentally unchanged 74 years later. Modern NASCAR has transformed dramatically. The sport introduced the next-gen car in 2022, representing the biggest overhaul in 75 years. These cars feature composite body panels, independent rear suspension, and standardized components that would have been science fiction in Smokey's era. Surface finish specifications are now measured with laser scanning equipment and must meet tolerances that make Smokey's mirror-smooth manifolds look crude by comparison. The sport is also looking toward the future with new technology. In 2024, NASCAR unveiled the ABB NASCAR EV prototype at the Chicago Street Race, showing what an electric NASCAR might look like. They're testing hybrid powertrains that combine electric assistance with traditional V8 engines. Computational fluid dynamics software now does in minutes what took Smokey months of trial and error to discover. Engineers can model airflow through manifolds and optimize designs before building a single part. Safety has also evolved dramatically. The 2025 season brought significant safety upgrades to the Gen 7 car, including stronger chassis construction, improved crush zones, and energy-absorbing foam in critical areas. These improvements stem from decades of learning what works and what doesn't. Built on data, Smokey and his contemporaries gathered the hard way. Modern NASCAR engines produce 900 horsepower from 358 cubic inches, while running at 9,000 revs per minute for 500 miles straight. The engineering precision required for that level of performance would astound Smokey. Exhaust headers are now works of art, designed with computational fluid dynamics and manufactured with investment casting techniques that produce glass-smooth internal surfaces. They're coated with ceramic thermal barriers that reflect heat and improve flow even further. But every single one of those modern headers owes a debt to that chemical porting hack from 1951. Smokey proved that surface finish mattered more than anyone thought. He showed that exhaust flow was absolutely critical to power production. He demonstrated that there was always room for improvement if you were clever enough to find it. Those lessons became foundational principles of modern engine design. So what's your take on Smokey's genius loophole? Do you think he was an innovator, or did he cross the line? Drop your thoughts in the comments below and smash that like button if you enjoyed this story. Subscribe to our channel for more fascinating racing history and engineering innovations. Until next time, keep pushing the boundaries.